guys, welcome to Coffee Field Maths. Today we're going to be dealing with discrete mathematics, specifically set theory and the basics of sets. What is a set? A set is a collection of unique, well-defined objects. I've got a couple of examples here with the set cat, dog and rat, which is obviously a well-defined and unique set as there are no duplicates and everything is very, very clear. The second is not a set, and the reason for that is because it is some animals. It's extremely general, it's not well defined, and there could be duplicates, which include some rats, some dogs, and some cats. So that doesn't fill the basic requirements for becoming a collection of unique, well-defined objects, which is a set. So there's a couple of different notations associated with sets, the common being roster notation, also known as tabular form, and set builder form. Those are the ones we're going to be dealing with today, and we'll use the example set A is equal to 3, 5 and 7 as our set for this slide. So in roster notation it's very clear. You've got A is equal to open bracket 3, 5 and 7 close bracket. That's the common form we're going to be using throughout the video, and the reason for that is because it's extremely easy to read. So we've also got set builder form, which says that x such that x is odd, but that is not descriptive enough because that could include 1 and 9. However, the set does only include 3, 5 and 7. So we'll expand upon that, and we've got where x is greater than or equal to 3 and where x is less than or equal to 7. So through logic you can deduce that the equivalent set from this one is going to be 3, 5 and 7, which is A, which is correctly defined. So the reason, as I said before, we're going to be using roster notation, also known as tabular form, throughout this is because it's a lot easier to read and a lot more obvious. We've got a couple of important symbols down the bottom, the most important being that of the empty set. So take notice of the notation for that one, and it'll come up later on. Also we've got the colon, which is such that, and the backwards E, which means that it's an element of. So we'll move on to cardinality. Cardinality is the number of elements in a set, generally. What that is it's notated as a straight line, a straight line, and that is the simple notation for it, and it'll tell you that that's what the question is asking and that's what it wants you to find. So we'll go with question 1. B is equal to the set of 1, 2, 3 and 4, and we've got to find its cardinality. So we'll simply count the number of elements in B, which is 1, 2, 3 and 4. So we've got B is equal to 4, the cardinality of B. We'll go on to C, where it becomes a little bit more challenging. We've got C is equal to the set of 9, 8, 7, 6, 5, 4, and the subset of 3 and 2. So we've got to find the cardinality of C. So we've got a set within a set. The important thing to remember is that when you've got a set within a set, the subset counts as a single element. So we have 9, 8, 7, 6, 5, 4, which are 6 elements, and then we have the set 3 and 2, which is 1 element. So the cardinality of C is 7. Question 3 says that we are trying to find the cardinality of the empty set. So the cardinality of the empty set is always 0 because the empty set does not have any values, and similarly the empty set is within every set. That is an important thing to remember, although it's not counted as a value. So we're going to go on to binary operations. Basically, the first is union. It is the most simple, and it's saying we're simply going to put the two sets into one set. So there's a visual representation, as I'll show you in a moment, but we're going to be dealing with the sets A equals 1, 2 and 3, B is equal to 3, 4 and 5. So as you see below, these are the two sets, and we're going to be showing them in this form just for a little bit of reference. The thing to remember is the symbol we're going to be using, which is big U, to denote that it is going to be unionized. So we're having A union B, which is equal to the set of 1, 2 and 3 unioned with the set of 3, 4 and 5. So simply putting all these elements into the one set equals 1, 2, 3, and 4, because 4 and 5, sorry. Remembering that we cannot have any duplicates in order for it to be a distinct set of objects. So when you shade that in, it is everything. It is both sets, which are then unioned together, so it is all elements. Beautiful. So I'll move on to intersection. The intersection is essentially finding the common elements between the sets, and it has the opposite symbol to union, so it is the U upside down. We are going to be using the same sets, which is A is equal to 1, 2, and 3, B is equal to 3, 4, and 5. So the intersection is written as A upside down U, B, and we're simply finding the elements that are common in both sets, which is 3. So when you shade it, it looks like essentially the intersection part between the two circles, and that intersection has the value 3. Set difference is a little bit more complex. It involves finding two sets in which of the first set the elements are not in both sets. It's a little convoluted, but essentially use the symbols minus or slash, and it's saying what is in the first set that is not in the second. So we've got A difference B, so sets 1, 2, 3 minus set 3, 4, 5. In the first set, elements 1 and 2 are not in the second set. So the common element is 3, therefore the set difference of A and B is 1 and 2. I can see how that might be a bit confusing, but it's simply just the first set has the importance, and you take out the elements that is common between the two sets. We'll move on to symmetric difference. Now this is even more complicated, and it's essentially what we've done before is we found the elements which are not common to both sets, and we're doing that again, but we're doing it for both sets. So we're using a triangle to depict the symmetric difference, and we're using the same sets, which is A and B, and we're writing it as A triangle B to denote A symmetric difference B. So the common elements between the sets are 3. So we simply union A minus B, which is 1, 2. We union that with B minus A, which is 3, 4, which equals 1, 2, 4, and 5. So those are the basics. I will be linking a worksheet in the description if you'd like to complete a couple more examples. But moving on to the next video, we'll be covering power sets, Cartesian product of two sets, covers, and partitions. Please like and subscribe. This is Fuel